Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video, we're going to be looking at more of gate logic, truth tables, and Boolean expressions, in particular Boolean expressions simplification. In our last video, we introduced the distributive property and also the complementation property, which are very useful for starting out and doing your simplifications. But as we get deeper into the art of simplifying, then we want to use some of the other properties as well. And so these two properties today are called absorption and consensus, and they can be very useful in simplifying. So in this video, I'm going to show you what those properties are and then give a demonstration of them, and then we'll end it at that point. Okay? All right, let's get started. All right, so we're at Boolean simplification, and the first property we want to look at is absorption. So absorption feels like it kind of gathers something in, it absorbs it and it takes it into itself, and something else disappears. And it sort of looks like that in the property itself. So the property is defined like this. X or xy is equal to x, and so the x absorbs the term xy. And so what is the logic behind this? How do we make sense of this property without doing a proof? You could do an algebraic proof, but I think it makes more sense to kind of think about it logically. And so this is an or. So the whole thing is going to be true if one term is true. And as long as one term is true, then all the other terms do not matter. So let's look at the left term, right? If x is true, then we have to ask the question, is y also true? But x is already true in this expression. So we say, if x is true, is y true? But we actually don't have to ask that question, because x over here by itself being true is enough for the whole expression, right? So if x is true, we're done. And then the whole expression is true. Well, let's look on this side. So if this is going to be true, then both x and y have to be true. But if x is already true, then we've already satisfied this first term on the left. So there's no way that this xy is going to add anything to our situation, okay? So we can also say that x is more general than xy, and xy is more specific. So we're saying if x, or if x and y. And so that might not seem easy to understand, but let me put it into different terms. So we're gonna say, yes, it's true if you have a cat, or if you have a cat and a refrigerator. And so it's okay, well, if you have a cat, you have a cat. Whether you have a refrigerator or not, you have a cat, so that would be true. So we're just looking at, do you have a cat? Do you have a cat? Or do you have a cat and a bike? And, well, if you have a cat, you've already satisfied that you've had a cat. So again, it just makes sense for to look at it that way. Hopefully that made sense to you, and you're thinking, do I have a cat? Is the cat by the refrigerator right now? Maybe I should take a bike ride. I didn't mean to do that to you, but hopefully you get that idea. So let's do an example. All right. So I'm going to say that f is equal to x, y, z bar, or y, z bar. All right. So, okay, where do we go from here? Well, we might look at this and say, you know what, we have y in both of these terms, and so why don't I just distribute out that y? And so I'm going to do that, and we got x z bar, or, oops, sorry, we'll go erase that, boom. I like this tool, it's a good tool, or z bar, okay. Now this looks familiar. This looks like that pattern. So do you have z bar, or do you have z bar and something else? And so this z bar is going to absorb right there the x is z bar. So let me just make sure that I'm writing what I'm doing here. So this is distribution, and then we're going to have y and z bar, and this is absorption. Okay, so look carefully, make sure you understand how that step came about, but that is now our answer. F is y, z bar. Now again, some of you are saying, Mr. Stanzik, you didn't have to do that distribution step, you could have done absorption right from the beginning, and you are correct. And so I could think of yz bar as a term in itself, as a sort of like a literal, if you will, in itself. It's a combined literal. And so we can think of this as the x in our expression for the definition of absorption. So if I have yz bar or yz bar and x, then we're going to absorb this x yz bar term, and we're going to end up with just yz bar. And if you look, that is what we ended up with in our expression. So yes, you could have taken that shortcut, but you didn't need to. And yeah, that would have been more efficient, but if you need to do the distribution first, do the distribution first until you recognize it. And so do what is easiest for you to get to the most simplified that you can get, okay? So don't worry if you didn't notice that. All right, let's move on to our next property. And this property is called consensus. These are kind of related to each other. Consensus. We all agree. I don't know how this actually relates, but I don't have a nice, clever little story about it. But we're going to make sense of this logically. So if we have x or x bar y, we end up with x or y. Okay, so let's take a look at why this makes sense logically. So what's changed? Well, we got rid of the x bar here, so that's no longer in there. So let's look at what could possibly happen. Here we're in an or, and then we have this and situation inside that or, right? So if I have x as being true, if x is a 1, okay, then we're done. This is true, right? And so that is the whole function is going to be a 1, the whole function is true. Or if x is not a 1, if it's a 0, then this immediately becomes a 1. And so the only thing that we're actually checking then is y. So if x is a 1, we're done. And if x is a 0, this is a 1, and we're only checking y. So we don't need to worry about this x bar there, because it'll always be a 1 if we don't satisfy the x. And so we can drop it. So we have x or y. All right, so hopefully that makes sense to you. If not, I might listen to it one more time and just try to process that. So let's do an example. Let's have x is xz or xy z bar. Again, I'm going to start out with the distribution of the x. And so we're going to have z or y z bar, and that's the distribution. And so now I see this form, z or z bar times something else. And so I say, well, if we have to use this term because z is not 1, then z bar is going to be, z is going to be 0, so z bar is going to be 1, so we don't need to include it. And so we end up with x or z, x and z or y. And that is our consensus. And then we might want to distribute back out like so, and we're done. Yeah, so that's where we have it. So hopefully you enjoyed that. Hopefully that has value for you. I appreciate your time. Thanks for watching, and continue to watch this series. We're going to have the next one on De Morgan's coming up soon. So I'm Mike Stanzik. This is Digital Electronics Classroom. Have a great day.